Hello students, in the previous module you've learnt how to find the square root of a number through repeated subtraction method. Now in this module we'll go through another method, that is finding the square root through prime factorization. So you've already learned what a prime number is. So can you tell me what is a prime number? So prime number is a natural number which is greater than 1 and whose only factors are 1 and the number itself. So can you tell me what is prime factorization? Correct. Prime factorization of a number is the method in which a number is factorized into the only prime numbers that multiply to give the given number. Let's take an example. So for example, what are the prime factors of a number 6? So they are 2 and 3. And that's because 2 multiplied by 3, it gives us 6. So the prime factorization of 6 is 6 is equals to 2 multiplied by 3, where 2 and 3 they are prime numbers. Let's now discuss how to find the square root through prime factorization. So for that, let's first compare the prime factorization of 6 and its square. So what is the square of 6? Yes, 6 square is equals to 36. And now the prime factors of 36 are 2, 2, 3 and 3. That is, the prime factorization of 36 is 36, which is equivalent to 2 multiplied by 2 multiplied by 3, which is further multiplied by 3. Okay, so here you can see that 2 and 3 they occur once in the prime factorization of 6, while in the square of 6, that is 36, they occur twice, or we can say that they occur in pairs. So we can infer that each prime factor in the prime factorization of the square of a number, it occurs twice the number of times it occurs in the prime factorization of the number itself. So here, if we pair the prime factors of 36, then we get 36 to be equal to 2 square multiplied by 3 square. Or this can be written as 2 into 3 whole square. Now next we are going to take the square root on both the sides, which gives us square root of 36 is equals to 2 into 3. And we know that square and square roots, they are inverse operations. So that's why they have cancelled each other out here. Or we can also say that we'll take one number from each pair. So this gives us square root of 36 to be equal to 6. Students, do you know why we have used prime factors and not any other factors? For example, we could have expressed 36 as 2 into 18, but we didn't do it that way. So can you think of a reason for this? Yes, here we cannot pair any factor. If we want to pair the factors, then we'll have to find the factors of 18 as well. Prime numbers are the only factors that cannot be factorized further. So it is easy to find the square root of a number through prime factorization method. You just have to follow some simple steps. So first we'll find the prime factorization of the given number. Then we'll pair the prime factors. After this, we'll take one factor from each pair. And then finally, we'll multiply them to get the square root of the given number. Okay, can you now find the square root of 256 through this method? Let's apply the same steps. So the first step will be to prime factorize 256. And the prime factorization of 256 is equal to 2 multiplied by 2 multiplied by 2, and this keeps on going till 8 times. Now we'll pair the prime factors. So 256 is equal to 2 multiplied by 2, which is further multiplied by 2 multiplied by 2, which is then multiplied by 2 multiplied by 2, and finally it is again multiplied by 2 multiplied by 2. So for finding the square root, we'll take one factor from each of these pairs, which gives us the square root of 256 to be equal to 2 into 2 into 2 into 2, and therefore we get 16. So here we can conclude that if all the prime factors of a given number they occur in pairs, then the given number is a perfect square. So using this method, we can also check if a given number is a perfect square or not. Can you check if 90 is a perfect square or not using prime factorization? So let's prime factorize 90. So this is the prime factorization of 90, and so we get 90 is equals to 2 multiplied by 3 multiplied by 3 multiplied by 5. Now students, just carefully observe here. Here only 3 is in pair, while 2 and 5 they do not occur in pairs. Therefore, we can easily conclude that 90 is not a perfect square. And now the question arises, can we make this 90 a perfect square by either multiplying or dividing it by any number? So for that, observe the prime factorization properly and think about it. Correct. Here we can see that 2 and 5 they are not in pairs. And we know that for a given number to be a perfect square, all its factors should be in pair. So what we need to do is, we need to multiply 90 by 2 and 5 to complete their respective pairs. So 2 into 5 is equals to 10, and therefore we'll have to multiply 90 by 10. This gives us 900. And now this 900 has all the prime factors in pairs, and therefore 900 is a perfect square. So we can say that 900 is the smallest multiple of 90, which is a perfect square. And what is its square root? Right, its square root can be determined by taking one number from each pair, which gives us 2 multiplied by 3 multiplied by 5, which is equal to 30. So 30 becomes the square root of 900. And this shows that if we have a non-square number, then we can easily find its multiple, which is a perfect square, using prime factorization. Okay, what if instead of completing the pairs of 2 and 5, we remove the numbers that are not in pair? Can we get a perfect square this way? Yes, exactly. Here 2 and 5, they are not in pairs, and 2 into 5 is equals to 10. So if we divide the given number by 10, then also we get a perfect square. So here 90, when it is divided by 10, it gives us 9, and its prime factorization is now equal to 3 into 3. Since the prime factor is in pair, so 9 is a perfect square. And what's its square root? Yes, its square root is 3.